Hey everybody, welcome back one more time for a section 3.5 video. We've worked on writing equations of lines so far in a couple different videos in this section, and now we're going to work on graphing whenever you're given an equation of a line. And in fact, that's goal 2, is that you will sketch the graph of a line given its equation. Alright, now what I'd like to do is go through every type of linear equation that you can be given and show you how you can use that given equation in order to sketch the graph of the line. Alright, starting with slope-intercept form. Alright, of course, you remember slope-intercept form is y equals mx plus b, and I've got a couple of equations here that are written in slope-intercept form, and we're going to use that in order to make the graphs. Well, very simple thing to do. If you understand the two pieces of information that are given to you whenever you have the slope-intercept form of the equation of a line. And those two pieces of information that you know about every line using its slope-intercept form are the slope and the y-intercept. So for instance, in the first equation, we know the slope is negative 3/5. We know the y-intercept is negative 1. How does that help you with the graph? Well, whenever you're trying to graph a line, you need 2 points, right? That's geometrically what we've learned about lines, is that through any 2 points there exists exactly one line. If we can find 2 points on our line, we've got our line. And the first point that we always have on our line is going to be the y-intercept. We now know the y-intercept is at 0, negative 1, so I'm going to plot a point at 0, negative 1. Alright, and then here's what the slope does for you. The slope tells you the ratio of the rise to the run for a graph. It tells you, it's basically a map of how you get from one point on the line to another point on the line. So, the fact that the rise is negative 3 and the run is positive 5 means that if I go down 3 units and 5 units from the point that I've already graphed, I'll get to another point on the line. So here we go. Down 1, 2, 3, over 1, 2, 3, 4, 5. Right there is going to be the second point on our line. And once I've got those 2 points, then all I have to do is make the line that goes through them like this. Alright, so that's all there is to graphing whenever you're given the slope-intercept form of the equation of a line. Let's try that with the second equation. In fact, you go ahead and do it, and then I'll go ahead and show you the work afterwards. Just keep in mind that you should think of the slope as a ratio whenever you're graphing. Okay, so you've thought this through. The slope is 4, the y-intercept is negative 2, and we're starting with graphing the y-intercept, so we're going to put a point right there at 0, negative 2. Then we're going to use the slope, which is 4 or 4 over 1, to know that we're going to go up 1, 2, 3, 4, right 1 from the first point that we graphed on the line. And then once you've got those 2 points, that is the line that you're trying to graph. Alright, so slope-intercept form, done, very easy. Now, what if an equation is given to you in point-slope form and you want to graph it? Well, also a very simple thing to do as long as you understand the 2 pieces of information given to you by the point-slope form. Now, just like with the slope-intercept form, the point-slope form tells you the slope of the line. So the slope of this line is 1/3. But remember, the other thing it tells you is the coordinates of a point that the line goes through. Since I've got an x minus 2 and a y plus 1, that means that the point 2, negative 1, is on the graph of this line. Now, you always have to start off with graphing a point, so 2, negative 1, we're going to graph that to begin. Then we use the slope, and we go up 1, right 3, and we place a second point. There we go. Now, by the way, instead of going up 1, right 3, and treating both the rise and run as positive, we could change both the rise and run to negative, because isn't a negative divided by negative also positive? And we could go down 1 and left 3 and make a second point, or a third point actually, on the line. And why would you care to do that? Well, kind of makes your line a little bit straighter if you can have 3 points that you know are on the line. Anyway, try and graph part D for me, please. Alright, you should have recognized that graph is going to go through the point 4, 2. Right there. And then the slope is -1. And so you can think of that, of course, as -1 over 1. Meaning that you could go down 1 and right 1. And that will get you another point that's on the line. Of course, we can also reverse that process and go up 1, left 1. Don't those points all line up? And I could keep doing that if I wanted to. But I've got enough to make the line. There we go. That's it. So very simple so far to graph equations that are written in the two forms that we've learned. There is a third form of a linear equation that I think you're familiar with. And we're going to learn how to graph real easily if you're given an equation in that form as well. And that form is called standard form. Now, we haven't talked about standard form yet this year, but the standard form of a linear equation is ax plus by is equal to c. And there's not a lot that I need to teach you about that other than the fact that when an equation is written in standard form, it means that the x's and the y's are both on the same side of the equation and the constants on the other side. There's some other rules, but that's what's relevant to this graphing thing. Now, the thing that's really easy to do whenever you're given an equation in standard form is it's real easy to find the intercepts of the graph. And so that's what we're going to do here is we're going to find the intercepts, both the x-intercept and the y-intercept. And that's a real simple process. Listen carefully to what I say. When you want to find the x-intercept of the graph of equation, you're trying to find where is y equal to 0, because isn't every point on that line have 0 for a y coordinate? So you let y equal 0 and you solve for x. I'm going to write that. And here's how that would look. You can see how I took the same equation, I substituted 0 in place of y, and then that ends up giving me 2x equals 6. So x is equal to 3. Now that tells me that the point 3, 0 is the x-intercept. And so I'm going to go ahead and graph that point 3, 0 right there. Then what I'm going to do is I'm going to find the y-intercept. And when you find the y-intercept, you're looking for a point that's on the y-axis, and you're guaranteed that the x-coordinate of any point on that line is going to be 0. So the way you're going to find the y-intercept is the opposite of what you did for the x-intercept. You're going to set x equal to 0, and you're going to solve for y, which will look this way. You see, this time I replaced x with 0, and so that makes it 0 minus 3y equals 6. And so we get that y is equal to -2 whenever x is 0, or in other words, that the point 0, -2 is on the graph. And so I'll graph that point 0, -2, and there I am with 2 points that I need to graph the line, and that is all I need to graph the line is 2 points. I didn't even have to know the slope. All I had to do was find the x and y intercept. Made graphing very simple. Make sense? All right, got one more for you to try. It's going to be a standard form equation. I want you to find the x and y intercepts and graph x minus 4y equals 6. Pause the video, make it happen. All right, here comes the x-intercept. When you replaced y with 0, you should have had x is equal to 6. So 6, 0 is your x-intercept, and you've got 6, 0 graphed then. Then for the y-intercept. When you replace x with 0, you end up with -4y equals 6, and -4 goes into 6, -1.5 times. You could have left this as an improper fraction, but this is actually exactly the instance where I prefer a decimal or a mixed number, because I know where -1.5 fits. 0 on a graph, 0, -1.5 is going to be right there. And we can go ahead and graph our line then. Easy as pie. That's how you graph lines. See you in class.